Okay, Assalamualaikum class. I hope all of you are doing fine and well inside your house. Okay, stay safe, do not go anywhere. All right, although we can't meet face to face, but we can always meet online, and that is okay. Right. I hope that the video that I'm giving you here will help you understand a bit more about programming. Okay, so basically we left off from chapter 2, right, which is on which is on sequential. Okay, today we're going into chapter 3, and that is selection control structure. All right, without wasting any more time, let's go into our chapter 3. Now the question says here, what does it mean when a program is executed sequentially? Okay, previously in chapter 2, we have done some very simple program where we don't have any if else, we don't have for loop, we don't have functions. Everything is simple. What you write inside your program is just very sequential, it's linear. So what you write at the top, it will be executed first, and then the next line and the next line until your program ends. Okay, so that is what it means by sequentially. The program will be executed in order, all right, from top to bottom. Okay, now inside a program, okay, your program doesn't have to be completely in sequence, because we can place some other things inside there like selection, we can put repetition, we can put functions. So whenever we place these things, your program will somehow execute depending on what you want your program to do. Okay, so if you have selection, then maybe your program needs to answer the question whether the question could be true or false. Okay, if you have repetition, then your program could be looping again and again. Okay, so depending on what you place inside your program can be executed differently. Okay, so it says here that selection structure allows a computer program to make decisions. Okay, when we talk about decisions, we usually will be asking some question. For example, this morning I was like, okay, I'm hungry. Do I go downstairs? So the answer is just yes or no. So depending on what our decision is, our action will be completely different to what we decide. Okay, again, your program can make decisions as well. So if you ask the computer a question, okay, then the computer can answer either it could be true or false. Okay, so again, I repeat, selection structure usually allows a computer program to make decisions. So there will be a question. The question will lead to an answer which could either be true or false. Okay, true means that the condition is met and it represented by 1, and false is when the condition is not met, which will be represented by 0. Okay, to help you further understand the concept of sequential and selection, I show you a very simple problem. Okay, a solution to a very simple problem. So let's say I want to make a cup of tea. Okay, the simplest way for us to solve that, okay, first of all, of course, you would get our cup. All right, to make a cup of tea, you need a cup. So let's draw a flowchart so that you can see a little bit better. So start. So once you've got your cup, inside there maybe you can place tea bag. Okay, then after that maybe you can pour water. Okay, after that maybe you want some sweetness, so you add sugar. Okay, then you stir. Lastly, add. So this is my solution to get a cup of coffee, to create a cup of tea, not coffee, a cup of tea. All right, so this is done in sequence because what you do is you're following the flow. Okay, firstly you place some tea bag, then you pour water, you add sugar, you stir, and then you get your cup of tea. Okay, but the thing here is, with this solution, it doesn't cater to every cases, because there are people who don't drink tea with sugar. So how can you cater to those cases? Okay, now which part do we need to change? Okay, so maybe around this part, because we don't want some sweetness inside that. So what we can do is we can get rid of that. Okay, so let's get rid of that and edit this flowchart so that we can cater to everyone who wants to drink tea, whether it can be sweet or it doesn't have to be sweet. Okay, so in order for us to decide, to make a cup of tea, whether it needs to be sweet or not, of course we need to ask some question, right? Okay, so if you want to ask some question, okay, inside your flowchart, you would need to use a diamond shape. So inside here, you need to place your question. Okay, what kind of question can you ask? The question, it needs to be, okay, the answer can only be true or false. So what kind of question can you ask? The question needs to be true or false, or yes or no, zeros or ones, okay, which means basically the same thing, okay? So the question that I can ask here is maybe add sugar, okay? So the question does lead to yes or no, okay? If the person wants some sugar, basically he wants the tea to be sweet, what you can do some process, which is place sugar, okay? So if the person doesn't want any sugar, then you can just end the process by saying stir and then end. Okay, now this is still not complete because the person who adds sugar, okay, whenever they add the sugar inside the cup, okay, it needs to lead to somewhere, it needs to end. Okay, so what it needs to do is you have to decide where it wants to go. Maybe after I place my sugar, I will end it by stirring it. Okay, so you see the difference. The previous one where there is no question, the program will be executed in sequence. But if we have a question that we ask, which can either be true or false, okay, the execution will be different according to what the answer was chosen. Right? So that is the difference between sequential and selection. Alright, so like I've mentioned earlier, when we have selection, we have question that we want to ask, right? Okay, so the question is actually a condition. So when we have a condition, okay, or a question, we need to compare values between two operands. So the result of comparison will either be true or false. So without these operators, you cannot make a question. It is not possible, okay? So when you have a selection, okay, the condition that you place inside there must contain one of these symbols, at least one, okay? So equals means equals to, not equals to, then you have less than, you have less than or equals to, you have greater than, you have greater than or equals to. So these relation operators allows your program to compare between two values, okay? So for example, if I show you this, let A equals to 4 and B equals to 10. Then A less than B. Is that a question? Yes, because you're asking whether A, is it less than B? So what you're doing is you're comparing between two values. Okay? So since A is 4 and B is 10, is A less than B? True. Okay? Then B equals to A. Is B equals to A? Is A, which is 4, B is 10, is it the same? No, so meaning that it is false. Okay, is A more than equals to B? The answer is false. Okay, since A is 4, B is 10. Okay, then the next one, let A equals to 7 and B equals to 5. Is A not equals to B? True, because they're not the same. Then is A more than B? True. Okay, is B less than equals to 7? True. Okay, and that is how we compare values inside our conditional statement. Okay, so keep in mind whenever you write a selection, the condition inside your selection structure, it needs to have one of these symbols. Okay, please remember that. Now, logical operators are used when there are more than one relational expression to evaluate at a time. It allows you to combine the relational expressions. The result of comparison will either be true or false. Now, if you take a look previously, this one is relational operators, whereas this one is logical operators. What are the differences between the two? Okay, relational operators are used to compare between values. Okay, compare between two things. Okay, you're comparing and then it will produce the answer either as true or false. Okay, whereas logical operators are used when we have more than one condition that we need to evaluate. Okay, maybe you want to combine them so that we are able to evaluate it a bit further. All right, so for example, If you see the logical operator not, okay, which is that exclamation mark, it means that it will produce the opposite answer of what is evaluated, okay? And then if you have the ampersand, it means and if you see that stick, the two sticks, it means or, okay? And when we compare, both of the condition needs to be true in order for that statement to be true, okay? For or, only one needs to be true for all of them to be true, okay? It might be a bit confusing, so I'll show you some example. Okay, so if I evaluate this, okay, 4 more than 8. Is 4 more than 8? Do the things that are inside your bracket first. Is 4 more than 8? False. So, since we have not at the front, okay, not false is equals to true. Okay, and then next question, 6 less than equals to 7. That is true. So, not true is false. Okay, so then we meet an and operand. Okay, and is used when we want to evaluate more than one condition at one time. Okay, so when we do this, evaluate the operations that are inside the bracket first. So 3 less than 9, that is true. Okay, then 10 more than 2, that is true. So true and true will be true. Okay, next one, 3 more than 6, that is true. 4 less than 6, 3 less than 6, that is false. 4 less than 6, that is true. So false and true will be false, because with and, both of these needs to be true. Only then it can be true, okay? Then we meet or, okay? 5 less than 7 or 9 more than 4. Is 5 less than 7? True. Is 9 more than 4? True. So true or true is true, okay? 5 more than 8. False, okay? Or 6 more than 2. True. So false or true is true. Because with or, if only one of them is true, then the whole statement becomes true, right? Then we have order of precedence, okay? So when you see a lot of symbols and you don't know which one to evaluate first, take a look at the order of evaluation, okay? So for example, let x equals to 3, y equals to 4, and z equals to 5. Then, take a look at this question. So which one do we do first? Of course, we need to do the relational operators first. Do the ones that needs to be compared first inside the bracket. So x more than y. Is 3 more than 4? False. Okay. Y less than z. Is 4 less than 5? True. So false and true is false. Okay. Then number 2, x equals to y. Is x the same as y? False. Then x equals to z. Is 3 equals to 5? False. So false or false is false. Okay. Z less than y? 5. Is it less than 4? False. So not false is true. So that is how we evaluate conditional statements inside an if statement. Okay. So let me give you this particular exercise. Evaluate the following conditional statements given that x equals to 40, y equals to 2, and z equals to 7. So let's try to do this together. So we'll do the first question. Okay, so x plus y less than equals to z times y minus y. So when we see this question, okay, do the operations first, okay, and then lastly we'll do the comparison. Okay, so x plus y is 40 plus y is 2 less than equals to z, which is 7, times y, which is 2 minus 2. So 40 plus 2 is 42 less than equals to 7 times 2. Again, we'll do the multiplication first. So 14 minus 2, so 42 less than equals to 12. So then we'll do the comparison if it's true or false. So is 42 less than equals to 12? So this is false. Okay, so this is the answer for the first question. Alright, so let's start with the next question. The second question says that not x modulus z equals to y. So this means that, okay, of course we need to do the ones inside the bracket first. So x is 40, modulus z is 7 equals to y, which would be 2. So we'll put 2 here. Okay, so we'll solve this one first. So 40 modulus 7 would mean the remainder. Okay, so this would be 35 and this is 5, so the remainder would be 5. So 5 equals to 2, not. Okay, so is 5 equals to 2? So that is false. So not false would be true. Alright, so let us move on to the last question. So the last question says that y more than z times y ampersand z minus z not equals x minus x. So this seems a bit complicated, right? So always do your operations first and then your comparison last. So the comparison here would be this, okay, and also this. Okay, so we'll do the other ones first. So the first one that we'll do is, so y, let's put in the values first. So 2 more than z would be 7 times y would be 2, ampersand z is 7 minus 7 not equals to x minus x is 40 minus 40. So again, the comparison would be here, here, and also the logical operators would be here. So do these other ones first. Okay, so 7 times 2 would be 14, 2 more than 14, then we have ampersand 7 minus 7 is 0, not equals to 40 minus 40 is 0. So after that, okay, higher ups would be this relational operator. So we'll do this one first and then we'll do that one. Okay, so 2 is 2 more than 14, so that is false. And okay, 0 is 0 not equals to 0, so that is false. So false and false would be false. So that is how we solve this question. Okay, so when it comes to selection control structures, there are 3 types of selection control structures. We have one-way selection, two-way selection, and multiple selection. Alright, so the one that we're going to be going into today is one-way selection and also two-way selection. Alright, so the first one we're going to be looking at is one-way selection. Okay, one-way selection only involves an if statement without an else statement. So if you take a look here, okay, so if, alright, whenever you want to write a selection, you must have an if statement. Okay, you have if, inside there you will have your condition. So your condition, it must contains at least one relational statement, either less than, greater than, equals to, wherever symbols you want to use in order to compare between two values. So that thing is needed inside your condition. Okay, so that this condition can be evaluated as either true or false. So if it's true, the statement inside the curly braces will be executed. Okay, if it's false, it will execute the next statement. Okay, and that is how if selection works. This is a one-way selection. Alright, so this is a little fun exercise for you to sort of think about. Okay, let's say I give you this problem. Okay, we have these two persons here, Amy and also Susan. Amy is holding a red box and Susan is holding a blue box. Now, both of them want to switch boxes, but they could only hold one box at a time. Imagine as if Amy only have one hand and Susan also have only one hand, and both of them are holding boxes each. Okay, Amy is holding a red box and Susan is holding a blue box. Now, both of these people wants to switch the two boxes. Okay, Amy wants to give the red box to Susan and Susan wants to give the blue box to Amy. So how can they do that if they only have one hand and the hand that they have are holding the boxes? Okay, so there is a way for you to solve this. Okay, so let us try to design a pseudocode that allows Amy and Susan to switch boxes. Alright, so let's try to design the pseudocode for this problem. So, as always, for pseudocode, we must have start. So the next one would be, we know that right now Amy is holding a red box, whereas Susan is holding a blue box. So, what we want to do right now is we want to switch these boxes. Okay, we want to give the red box to Susan and the blue box to Amy. So how can we do that? Since Amy and Susan is only able to hold one thing at a time, okay, we would need a help from another person. So let's say we'll draw this other person and call this Jenny. Okay, so Jenny is able to hold one box at a time as well. Okay, so right now Jenny doesn't have anything on hand. Okay, so what we can do right now, okay, we can tell Amy to give Jenny the red box. So when we tell Amy to give Jenny the red box, Jenny will now hold the red box. So Jenny will now hold a red box. Okay, after that, okay, what can we do? Since Amy, all right, is holding the red box, okay, and she gave it to Jenny, so now Jenny has the red box. So logically, Amy doesn't have any boxes on hand. All right, so what we can do is, okay, we can now give the blue box to Amy since she doesn't have any boxes on hand. Okay, so this blue box can now be given to Amy. Okay, so right now Amy is holding a blue box. Okay, since Amy is holding a blue box, Susan will now have an empty hand. So what can we do now? We can tell Jenny to give the red box back to Susan. Okay, so since Jenny will be giving Susan the red box, okay, now Susan will hold the red box. So have we met the objective? Yes. Amy is now holding a blue box and Susan is now holding a red box with the help of an extra person called Jenny. So basically this is how we solve this particular problem. Okay, you will find that this problem will relate to the next problem that I'm going to give you. Okay, so let us try and solve this particular question. The question says that write a program that will receive two integers. If the first number is greater than the second number, switch the two numbers. If you notice that this question is pretty similar to the problem that I gave you before, which was the Susan and Amy who have boxes and they want to switch boxes, right? Basically for this question, you can use the same concept to solve this problem. Okay, so these are the two sample input and output. So for example, if we enter the first number as 22 and the second number as 10, okay, we will get the first number as 18 and the second number as 20. Okay, the numbers will be switched since the first number is greater than the second number. But if the first number that was entered is smaller than the second number, then it will not be switched. The output will be the same. For example, first number equals to 3 and second number equals to 5. Alright, so let us try and solve this particular question. So whenever you write a program, okay, keep in mind of the things that you need to have. Include IOStream, using namespace std, in main, etc. Okay, so now we're going to write the code. So to solve this problem, the first thing that we need are the two numbers. Okay, so how to get the two numbers? So we do an output, enter first number, cin, num1, cout, enter second number. So this will be the input which you will need from the user. Okay, since we're using these two variables, don't forget to declare them. So int num1 and num2. Okay, so again the question says if the first number is greater than the second number, of course again here we would need to do a selection. So if, so what's the condition that we need to do? Num1 more than num2. If number 1 is greater than number 2, then what are the things that you need to do? You need to switch the two numbers. So how can we do that? Okay, so for example, if num1 is holding 20 and num2 is holding 10, so how can you switch them? We use the same concept as Amy and Susan before. Okay, as we all know, variables can only store one data at a time. Okay, so firstly, okay, num1 equals to 20, num2 equals to 10, for example. So what we can do here is num1, okay, we can allow, basically we need the help of Jenny, like the one I showed before, right? Okay, so let's name this person as temp. Okay, temp will be like Jenny. So temp equals to, so let's say you want to give the value from num1 to temp. So you write num1. Okay, so this is like Amy. This is like Susan. So this will be Jenny. Okay, so now we can give the number from Susan back to Amy. So what we can do here is we can write num1 equals to num2. So this represents Amy. So Amy has received the number from Susan. Okay, and lastly, Susan can now, so Susan is num2, can now receive the number from Jenny. Alright. Then lastly, all we need to do is just display the numbers. So first number, num1, cout, second number, num2. Okay, since we use these two variables and also temp, we need to make sure that we declare the temp as well. So this represents Jenny, this represents Amy, and this will also represent Susan. So basically this is how we solve this particular problem.
Alright, so let's move on to two-way selection. Okay, one-way selection is when we only have an if statement. Okay, a two-way selection is when we have an alternative. Okay, instead of just an if statement, okay, it also have an else statement. Okay, so of course you need an if statement where you have a condition. If this condition is true, the statement inside the curly braces will be executed. But if this condition is false, meaning that otherwise, it's like an otherwise lah. Okay, otherwise the statement, the next statement will be executed. Okay, so whatever that is inside else will be executed if the condition here is false. If the condition is true, it will go inside here. If the condition is false, it will go inside this else statement. Only then, after all of these are done, it will move on to the next statement that is after that. Alright?
Alright, okay, so let's move on to the next question. Okay, so this problem states that we need to draw a flowchart based on the program given. Alright, so again, to draw any flowchart, okay, the first thing that we need is of course start. Okay, so once I've done that, the next line that I need to look at would be the input. Okay, since the declaration has nothing to do with flowchart, so the input would be hours worked. So the keyword that we use inside the flowchart for input would be read. Read hours worked. Okay, and the shape would be a parallelogram. Okay, after that, we'll notice that there is an if statement. So since an if statement, we need a diamond for this. Since we have a decision to make, so we have a condition. So inside here, we'll write the condition, which would be hours worked is more than 40 and hours worked less than 60. Okay, so this thing can either be true or false. So if it's true, there's a process inside there. So it is hourly rate equals to 5.0. Since this is a process, it's a rectangle. So however, if it's false, okay, we will have an else statement. So inside that else statement is a process, hourly rate equals to 4.0. Okay, so after that, okay, since after the else statement, there will be another statement, which is pay equals to hours worked times hourly rate. So pay equals to hours worked times hourly rate. Since this is a process, so a rectangle for that. Okay, then lastly is display. Display the pay earned is RM. Okay, so what you want to display here is the pay. Okay, so this is a parallelogram. All right, and lastly, end. Okay, so again, we are not finished, because after this, okay, after hourly rate equals to 5.0, where does it go? Does it go to here, or does it go to here, here, or here? Okay, it doesn't go to hourly rate equals to 4.0 because this is for else statement. Okay, so instead, this goes to the next statement. Once it is done, it will skip the else. It will go to pay equals to hours worked times hourly rate. Okay, so this is the flow chart for this particular problem. The next question said, if the hours worked is keyed in as 50, meaning that the hours worked, okay, is keyed in as 50. So we will need to check with the condition. Is this true or false? So is 50 more than 40? So that is true. Is 50 less than 60? That is true. So since both of these are true, then it will go inside here. Meaning that, okay, 50 is in between 40 and 60. So the hourly rate will be 5.0. Okay, then it will go down here, pay equals to hours worked, which is 50 times hourly rate, which is 5.0. So 50 times 5.0, we will get 250. So it will be stored inside pay. So in the end, display the pay earned is RM 250. So that will be the output for that particular question. Okay, so for the next question, okay, it said that if the hours worked is keyed in as 100, okay, what will be the output displayed on the screen? Since the hours worked is keyed as 100, this is false. Why is this false? Because is 100 more than 40? Yes, but although this is true, is 100 less than 60? False. Since this is and, both of the statement needs to be true. Okay, so this means that 100 is not in between 40 and also 60. So it will go down here. Alright, so the hourly rate would be 4.0. So in the end, pay equals to hours worked, which is 100, times hourly rate, which is 4. So the pay would be 400. In the end, it will display the pay earned is RM 400. Okay, so that is how you solve this question. Okay, so moving on to the next question. Okay, it says here that write a program that will read an integer number. Check whether the number is positive or not positive. The program in the end should display an appropriate message for that number. So for example, if we enter the number 24, okay, the message positive number will be displayed. Okay, however, if you place negative 56, the message negative 56 is a negative number will be displayed. So how do we determine whether a number is positive or negative? So let us try and do that and write a program for that. So first thing that we need is we need an input. So to do an input, okay, of course you need to ask the user first, enter a number. Okay, so cin num. So this num would be our input. Okay, so again we need to declare int num. So what do we do with this number? We want to check whether this number is positive or negative. So how do we do that? So we know that a number will be positive if it is more than 0. Okay, so what kind of question we need to ask? So we need an if statement. So if, so how do we know if a number is positive? You would say that if the number is more than 0, then it will be a positive number. So cout, okay, num is a positive number. Okay, otherwise, okay, so meaning that if the number is less than 0, or if the number is not more than 0, then it will go inside here. Okay, so cout num is a negative number. Okay, so depending on the number that the user enters, for example, if they put in 20, so it will check, is 20 more than 0? Yes. So it will display 20 is a positive number. If here I put negative 10, so it will ask the first question, is negative 10 more than 0? No. Then it will go inside the else statement and execute. Negative 10 is a negative number. So basically this is how you solve this problem. Okay, so this would be the last exercise for this segment. Okay, the question says write a program that will read an integer number. Okay, based on that number we need to determine whether that particular number is divisible by 2 and or divisible by 5. Okay, for example, if the users enter 24, 24 of course is divisible by 2, but it is not divisible by 5. Okay, so if the user enters 55, we know that 55 is not divisible by 2, but it is divisible by 5. If the user enters 7, so of course 7 is not divisible by 2 and it is not divisible by 5. If the users enter 60, 60 are both divisible by 2 and also 5. So how do we solve this problem? Okay, again, we need a number. Okay, so this number comes from the user. So what kind of question can we ask in order to determine whether that number is divisible by 2? Do one by one. Okay, do not complicate things. Do answer or solve your problem one by one. So let's do the first one, which would be, how do you find whether a number is divisible by 2? So a number is divisible by 2 when we divide it, it does not have any remainder. So if you want to check for remainder, the operators that we would use would be the modular sign. Okay, so we would write here, if the number, when we divide it with 2 and there is no remainder, this number would be divisible by 2. Okay, so we will write here, Cout num is divisible by 2. Okay, so if the number have remainders, meaning that the number would be not divisible by 2, so we would have else here. Okay, Cout num is not divisible by 2. Okay, but the question did say we need to check for divisible by 2 and also divisible by 5. So the concept is the same. All you need to do is just copy and paste the first one and just do one for the second one. Okay, this first part is for divisible by 2 and the second part would be divisible by 5. Okay, so we need to change everything here. Okay, so I take an example. For example, if the user enters here as 20, okay, so logically 20 would be divisible by 2 and also divisible by 5. Okay, so we would go through the first if statement. 20, when we divide it by 2, does it have remainder? No, so of course it will go inside here, so this will be displayed. Okay, and this will be skipped. After that, it will move on to the next if statement. Is num, which is 20, modulus 5 equals to 0? Yes, because when we divide 20 with 5, there is no remainder. Then after that, this particular line will be displayed. Okay, so this is the case for number that is both divisible by 2 and 5. So let's say if we choose 15. Okay, 15, when we divide it by 2, it does have a remainder, so it will display this part. 15 is not divisible by 2. So once done that, then it will move on to the next line. If num modulus 5 is 15, when we divide it by 5, does it have a remainder? No, so meaning that 15 is divisible by 5. Okay, so we know that this solution or this program will be able to solve this problem.